So in these notes, we're going to be looking at solving some word problems using systems of equations. So we're going to write some equations for these word problems and then solve them. So we got 3 examples we're going to work through. Example 1 talks about cookies and brownies. So we have 7 cookies and 4 brownies. That weighs a total of 295 grams. And then 3 cookies and 8 brownies weigh a total of 315 grams. So the question asks us to determine the weight of each cookie and each brownie. So we're assuming all the cookies are the same weight and all the brownies are also the same weight. So what we're going to do is we're going to set up 2 equations. We're going to have 7 cookies plus 4 brownies, and that is going to weigh a total of 295 grams. So C represents the weight of each cookie, and B represents the weight of each brownie. And then we're going to have another equation, which you probably already have figured out. 3 cookies plus 8 brownies is equal to 315 grams. So, how do we solve this if we have 2 equations and 2 unknowns? Well, what we can do is we can take, since this is 4b and that's 8b, I notice that 8 is just double 4. So if I take this top equation and I multiply it by -2, then I'm going to have an 8b on the second equation and a -8b on the first equation. So let's do exactly what I'm talking about here. That is going to be 7. Oh, I already messed up, didn't I? We're going to multiply by -2. So that is -14c minus 8b equals -590. And then I'm just going to rewrite the second equation. 3c plus 8b equals 315. So, once we have this, we're going to add these 2 equations together. And the 8b and -8b cancel out. So what we get is we get -14c plus 3c is -11c. And then -590 and 315 will be -275. So now the nice thing about this is the b is canceled out, so we got rid of the brownies in the equation, and now we just have c for cookie. So we're going to divide by -11, and c equals 25. So that means that the cookies weigh 25 grams. Then all we have to do is just plug it into one of the original equations and solve for the brownies. And so it does not matter which one you choose. I'm just going to arbitrarily choose the second equation. And I'm going to rewrite that over here. 3c plus 8b equals 315. And I'm going to replace this c with 25. So 3 times 25 plus 8b equals 315. So 3 times 25 is 75. We're going to subtract 75 from both sides. And we get 8b equals, if I do 315, I'm just typing this in my calculator, minus 75, we get 240. I should have been able to do that without a calculator. Divide by 8, and I can do this one without a calculator. This is 30. So, determine the weight of each cookie and each brownie. We did that. The cookies each weigh, so cookies each weigh 25 grams, and the brownies each weigh 30 grams. Sorry if you can't read my penmanship there. All right, let's look at example number 2. Example 2, in 2018, Paul George set the NBA record for the most points scored by a player who had 0 free throw attempts. So George didn't take 1 free throw, and he scored 43 points while making 19 baskets in total. It's a very rare feat in the NBA to go an entire game without even attempting a free throw. So the question is, how many 2-point and 3-point baskets did Paul George make? So the only thing that they tell us is that he didn't make any free throws, which really doesn't affect this situation. They tell us he scored 43 points, and he made 19 baskets in total. So what we're going to do is we're going to say, it says how many 2-point baskets and 3-point baskets did he make? So what I'm going to do is I'm going to call 2-point baskets X and 3-point baskets Y. So let's set up a couple of equations, and it may not be super obvious, but the first equation I'm going to do is X plus Y equals 19. Because he made 19 total baskets, and so if you add up all the 2-point baskets and 3-point baskets, that should equal 19. Now, if you add up all the points from those baskets, it should equal 43. So the other equation is going to be 2x plus 3y equals 43. All right, there's a couple of different ways we could go about solving this. One way is we could take this first equation and we could solve it for x or y and then use substitution and plug it in for x or y into the second equation. Or my preferred method is to use elimination. And so what I'm going to do is I'm going to multiply this by -2. It's not better, it's just another way of doing it. I just tend to like using elimination. But if you like substitution, that works wonderfully here as well. So I'm going to multiply everything in the first equation by -2, so we get -2x minus 2y equals -38. And then I'm just going to rewrite the other equation, 2x plus 3y equals 43. And then we just add these two equations together. So the -2x's cancel out, and we are left with -2y plus 3y. Look at that, that's just y, that's nice. And then -38 plus 43 is 5. So what that means is he made 5 3-point baskets. So Paul George made 5 3-point baskets. And, well, if he made 19 total baskets, then that means he made 14 2-point baskets. So how did I get 14? Well, basically what you can do is you can take the original equation and you can say x plus 5 equals 19, subtract 5 from both sides, and x equals 14. So George made 14 2-pointers. All right, let's look at one more example, and then we'll call it good for this type problem. So you've got 60 coins, and the total dollar amount is $4.35. If those 60 coins are only dimes and nickels, so if you only have dimes and nickels, how much of each coin do you have? So we have dimes and nickels. We'll call those D and N because they're dimes and nickels. So it says we have 60 coins. This is a lot like that basketball problem we just did. So if we have 60 coins, then all the dimes and all the nickels should equal 60. So it might be 30 and 30, it might be 20 and 40, it might be 31 and 29. We'll figure that out. And then the dollar amount is $4.35. So for every dime, it's 10 cents. So the way we set that up is 0.10D, because it's 10 cents for every dime. And then 0.50, 0.05N, because it's 5 cents for every nickel, and that equals 4.35. So those are going to be our two equations. Okay, I know I said in the last problem I prefer elimination, and I still do, but I'm going to do one with substitution just so that we can kind of see an example there. So what I'm going to do is solve this one for d. And I'm going to subtract n from both sides, so we get d equals 60 minus n. So then what I can do is, in the second equation, I can replace that d in the equation with 60 minus n. So 0.10 times d, which is 60 minus n, plus 0.05 n equals 4.35. So, simple substitution. We solved for one letter, plugged it into the other equation. So now we're going to distribute that 0.10 in, and we get 6 minus 0.10 n plus 0.05 n equals 4.35. So if I combine like terms here, I get 6 minus 0.05 n equals 4.35. I'm going to subtract 6 from both sides. I get 0.05 n equals, let's see, negative 1.65. And then I'm going to divide by negative 0.05 on both sides. And I'm going to type it in my calculator here while you patiently wait for me. 1.65 divided by 0.05, and I get 33. So what does that mean? That I have 33 nickels in total. Nickels. And then we know that we had 60 coins total, so if I do 60 minus 33, that's 27. So that means there were 27 dimes. Okay, so what did we take away from this situation? Well, you're always going to come up with two equations and two unknowns. With this problem and the basketball problem, there was one equation where it was the total number of coins or the total number of baskets. And then there was another equation where it dealt with the amount that the things were worth. And so in this one, it was how much money they were worth. In the basketball one, it was how many points it was worth. And so this, other word problems might look pretty similar to these, so make sure you try to set them up in a similar fashion. So that is solving a few word problem examples using systems of equations.